doesn't make it easy for me to help. All right, so let's have a look then at reaction yield. So for actual reactions occurring in industry, we don't get 100% yield. So the 100% yield is the theoretical yield. So if you're doing a limiting reactant or a mass-to-mass calculation and you're working out the mass of a product, that is the maximum mass that you could possibly actually obtain. And in reality, yeah, it's often quite a bit less. And if you can get a yield of greater than 90%, then that is an excellent yield. And a lot of the chemistry for industry is around increasing yields. Because if you imagine that you're making something, iron, steel, hydrochloric acid, if you've got a process that's 70% efficient and you can make changes that makes it 71 or 72% efficient, then you're making more money. And so this is a very big focus for industry. So a percent yield, the actual yield divided by the theoretical yield multiplied by 100 to make it a percent. So this, remember how I said that the actual yield is generally less than you calculate? So this is from the balanced equation. Or mass-to-mass calculation. And this is what's measured. Okay, and as it says on page 33, there are other reasons why you may not be able to get 100% yield, and equilibrium reactions is a big reason for that. And we will look at them right at the end of term 3. So on page 34 is our first example. We've got 10 grams of calcium carbonate reacted with excess hydrochloric acid, and we produce 3.9 grams of carbon dioxide. We're given the equation, so we don't need to worry about that. Grams of calcium carbonate, so that's what we started with, and we've produced 3.9 grams. So this is my actual yield. But we know that we can't go from mass to mass, we need to go through our moles. So the first thing we want to find is the moles of calcium carbonate. And using that ratio here for our sample mass to molar mass. And I'm just going to do it a quick way. So we've got 40.1. So I've just divided the sample mass by the molar mass, 0.0999 moles. So that's what we have of the calcium carbonate. Now if I look at my mole ratio, the calcium carbonate to carbon dioxide, 1-to-1, isn't it? Yeah? So therefore, the theoretical value for N for the carbon dioxide oops, is 0.0999 moles as well. And now I need to convert that to the theoretical mass. Yep, so if I rearrange my equation to find the sample mass, it's going to be the moles multiplied by the molar mass. So the theoretical mass of carbon dioxide will equal the moles multiplied by the molar mass of carbon dioxide. And we get 4.40 grams. So now we know the theoretical yield and we know the actual yield, and we can now find the percent yield. I don't know why I keep writing 3. So it's our actual value, 3.90, divided by the theoretical, multiplied by 100, 88.6. Does that make sense? Yep. Where do students make mistakes? In getting a bit mixed up about which masses to use where. So this sort of thing where you can annotate the equation, like write masses on there so that you can see what you're doing and where you want to go from there. Just going to stop.